What if the force pushing our universe apart isn't as steady as we once believed? For decades, scientists have thought of dark energy as a constant, a silent driver of cosmic expansion. But new supercomputer simulations are now shaking that very idea. They suggest that dark energy might actually change over time, potentially rewriting our entire understanding of the cosmos itself. Ever since the early 20th century, astronomers have known our universe is expanding. But the real shock came when they discovered it's not just expanding, it's accelerating. This surprising behavior is blamed on dark energy, a mysterious property of space-time that relentlessly pushes galaxies away from each other. Our standard cosmological model, known as lambda cold dark matter, or CDM, assumes this dark energy has been constant throughout all of cosmic history. This assumption has worked pretty well so far, but it might be hiding a deeper, much more complex reality. Now, fresh data is starting to pour in from the Dark Energy Spectroscopic Instrument, or DESI for short. And this new information is hinting that dark energy might be dynamic, not fixed. If that's true, it means the story of our universe's expansion is far more intricate than scientists ever imagined. But figuring out how a time-varying dark energy would affect the growth of galaxies and all the massive structures in the cosmos is no simple task. In fact, our current theories really struggle to explain it. To explore this mystery, a team led by Associate Professor Tomoki Ishiyama of Chiba University, along with collaborators from Spain and the USA, ran some of the largest cosmological simulations ever attempted. Their goal was to see just how a changing dark energy could reshape the universe. Using Japan's incredibly powerful Fugaku supercomputer, the team created 3 massive simulations. Each one was a staggering 8 times larger in volume than any previous effort. One simulation followed the traditional, constant dark energy model. The other 2 tested versions of what's called dynamic dark energy, or DDE. One of these was based directly on DESI's latest observations, and what they found was truly striking. On its own, dynamic dark energy caused only modest changes to the simulated universe. But when they combined it with another one of DESI's findings, specifically a roughly 10% increase in the amount of matter in the universe, everything changed. A higher matter density means stronger gravity, and stronger gravity allows massive galaxy clusters to form much earlier in cosmic history. In fact, the model based on DESI's data predicted up to 70% more massive clusters in the early universe, fundamentally altering the cosmic landscape we see today. The team didn't stop there. They also looked at something called baryonic acoustic oscillations, or BOs. Think of these as ancient sound wave patterns. Fossilized echoes from the Big Bang that astronomers use as a cosmic ruler to measure vast distances. In the DESI-informed model, the BAO signal shifted by 3.71%, which closely matches what we see in real observations. Even the patterns of how galaxies clustered together lined up beautifully with DESI's data. This provides strong evidence that this new dynamic model is capturing something real about how our universe truly evolves. As Dr. Ishiyama explains, it turns out that small variations in things like matter density might play an even larger role in shaping the universe than dynamic dark energy does on its own. With next-generation surveys like DESI and the upcoming Subaru Prime Focus spectrograph, these simulations offer a crucial roadmap for interpreting the cosmos with unprecedented precision. The universe may be far more dynamic than we ever imagined, and we're only just beginning to understand its secrets. If you enjoyed this deep dive into the mysteries of our cosmos, let me know your thoughts in the comments below, and be sure to subscribe for more mind-blowing science stories. Thanks for watching.